Section 6.4 is on nth roots. Sounds a little strange, let me explain it. The nth root of a number is the inverse of raising that number to the nth power. And we just use n to mean any number. So it can be 2, in which case you'd be doing a square root. It can be 3, in which case you'd be doing a cube root. Here's the way it works. So we can say that 4 to the third power is 64, or 4 cubed is 64. To undo that, we take the cube root of 64, and that gives us 4. All that means is what number times itself 3 times gives us 64, and that number is 4. So the way we write this in kind of a formula notation is a to the n equals b if and only if the nth root of b is equal to a. And we call n the index, whatever that root is that we're taking. That's the index. So a little bit of notation here. So you're very familiar with square roots. So we can say that the square root of 49 is 7. But even though negative 7 times negative 7 equals 49, positive 7 is what we call the principal square root of 49. So when we say square root of 49, we're only talking about 7, not negative 7. If we put a negative in front of the square root sign, so negative square root of 49, that equals negative 7. And we say that that is the opposite of the principal square root. And if you want to talk about both numbers, then you put this little plus or minus sign in front of it. So plus or minus the square root of 49 is plus or minus or positive or negative 7. And that gives us both of the square roots of 49. So let's take a look at a bunch of examples here. So we need to simplify each one of these. Number 1 is positive or negative square root of 121 x to the 4th y to the 8th. So since there is no number kind of right in here, it's assumed that it's a square root. So that's going to be equal to, another way to think of this is, so we need to put that plus or minus in front, is what number times itself gives us 121. So that's 11 squared. X to the 4th is actually x squared times x squared. So why am I writing these as powers of 2? Because we're taking a square root. And y to the 8th is y squared times y squared times y squared times y squared. Remember that when you're multiplying powers, you add the exponents. Okay, so simplifying that, plus or minus, this is going to turn into an 11. And then I have an x squared and an x squared, 2 of those, so that's going to give me 1x squared. And then I have a y. This is going to turn into 1y, another y, another y, and another y, or y to the 4th. And that's my final answer. Okay. Number 2. So I'm going to put my negative there because that's going to be in my final answer. Now let's take a look at this. I have x squared plus 4x, that whole binomial to the 12th power. Now I don't want to write this out like 6 times, write x squared minus plus 4x in parentheses squared 6 times, because that's how many times I would have to have it to get it to the 12th power. So this is actually going to be equal to negative quantity x squared plus 4x to the 6th power, because there are 6 parentheses squared underneath there. So 12, something raised to the 12th power, is 6 of those squared. I'll box that. Now a cube root. So here we have the cube root of negative 27 x to the 9th y to the 12th. Okay, here's a little bit of a shortcut. If it's a cube root, and in this case it was a square root, so we were looking for 2's. It's a cube root, we're looking for 3's. So when it comes to the exponents, we're pretty much just going to be dividing, and that'll get us our answer. But let's deal with this negative 27. What number times itself 3 times gives us negative 27? That number would be a negative 3. And I'll show you in a little bit how to do some of this on your calculator. So there are 3 x cubes that make x to the 9th. So the cube root of x to the 9th is x cubed. There are 4 y cubes that make up y to the 12th. So that's going to be y to the 4th. And as you can see, the shortcut way is to just divide the exponent by the index. Okay. Number 4, the fourth root of 81, x to the 12th. And again, I'll show you in a minute how to use your calculator to get the fourth root of 81. You could factor tree this and see what number, but it ends up being a 3. And again, we can use our shortcut of doing the exponent divided by the index, x cubed. But there's actually something kind of strange going on here. I have to put absolute value bars around this because I need to make sure x could be a negative number. And when I cube a negative number, I get a negative number, but I need for that number to be positive, so I have to put absolute value bars around it. So here's the rule you need to memorize. If you take an even root, so if you take an even root, and in this case it was the fourth root, of an even power, and my power in this case was 12, then you need to use and you get an odd power, sorry. And you get an odd power, which I did. I got a 3. Then you need to use absolute value bars. So I took the even root, the fourth root, of an even power, which was 12, and I got an odd power, so I have to put that part of the expression in absolute value bars. The way I remember this is even, even, odd. Even root of an even power, odd answer, use the bars. And let's take a look at this one here. So I have the 8th root of x to the 16th power, y to the 8th power. So dividing, that's going to give me x squared. Okay, so do I need to do bars? No. I took the even power of an even, or an even root of an even power, and I got an even answer. So no need for bars there. Now to take the 8th root of y to the 8th, that's going to give me y to the 1. And again, I took the even root of an even power, but I did get an odd exponent, because remember there's a 1 on there, so the y needs to be in absolute value bars. Okay. And the last couple problems here are very straightforward. We're going to use a calculator to approximate each value to 3 decimal places. So you probably already know how to use the square root function in your calculator. So just punch that into your calculator, and that's going to give us approximately 0.656. But let me take a minute and show you how to use the cube root function. Okay, so you're going to want to use the math menu right here. Pull that up. And you may have seen this before. You actually have a cube, but you also have a cube root here in number 4. So let's go ahead and select number 4. And then we're going to put in our number, which is negative 168, and then hit enter. And that gives me negative 5.518, rounded to the nearest tens, hundreds, thousandths. Now our next one is the 6th root of something squared. So let me show you how to do a root other than a cube root. So going back to our math menu, you see number 5 here has a little x kind of where the index is. So that's the function we're going to use. But for this calculator, I believe, let me see. No, I can actually, in some calculators, if you have an older calculator, you might have to put that index in first, but in this case I don't have to because it's blinking. So I can put a 6 in there, and then I think I have to arrow over to get under the radical sign, and then I did have parentheses around my number, 8,912. That thing's squared. Okay, and now I can hit enter. And I get my answer, 20.733. So in this section, we took a look at nth roots, and it sounds kind of strange, but it's just talking about taking the root of a number higher than the square root. So we talk about a cube root, a 4th root, or even an 8th root, and how to do that. And remember that rule that we talked about when you need to use absolute value.